Hello, Math 150. We're looking at the next learning objective in section 3.2, and we are talking about Descartes' rule of signs today. Now, there's a lot of words. It's not that hard. The words make it a lot more confusing than it has to be. The bottom line is that we are looking for alternating signs in our polynomial. So let me talk a little bit about that, and we'll get started, okay? So Descartes' rule of signs, here's the deal. We set this function equal to 0, these polynomials equal to 0. We're looking for the number of solutions. Those zeros are called roots, so the same thing. We're trying to get an idea of how many zeros every polynomial has, because if we know ahead of time, it will make it easier to solve these things, okay? So we're talking about the number of positive answers and the number of negative answers. So the first part of Descartes' rule of signs is the number of positive zeros will either equal the number of sign changes that we see in our polynomial when we write it in decreasing order, or it will equal that number less than an even integer, okay? So if we see 7 sign changes, we could expect that there will be 7 solutions, or we can reduce by 2 each time. There could be 5, there could be 3, there could be 1. Those are the number of positive zeros we're talking about, okay? The second part of Descartes' rule of signs says that if you're looking for the number of negative zeros, okay, now we're talking about answers that are less than 0. We're going to count the number of sign changes, this time not of the original function, but of f of negative x when we plug in a negative. And we'll count that number of sign changes. The number of negative zeros will be that number of sign changes or that number reduced by an even integer. So if we get 4 sign changes this time, okay, the number of negative solutions we're going to find is going to be 4, 2, or 0. Okay, always go down by 2. Let's look at this in practice. We'll really make this work. Short section today, just a couple of examples. So in this first one, we're going to look for the number of positive zeros, okay? The first thing we're doing is we're going to put this in decreasing order. So the highest exponent, and then we're going to go down each time, and we're going to look for the number of sign changes. So from here, we've got a positive. Here, we've got a negative. This number is a positive. This one's a positive. This one's a negative. This one's a positive. So I'm looking for the number of sign changes. There's 1. There's another. This is not a sign change, so we don't count that. Here's a sign change, and here is another sign change. When you count those sign changes, there are 4 sign changes. So that means we will either have 4, 2, or 0 positive solutions. Positive solutions. Now, again, this doesn't tell us the solutions. It just tells us the number we can expect. So now when we go down to the next one, in this case, we are plugging in a negative x everywhere. So for all of these, we're plugging in a negative x. Now remember, when you do a negative to an even power, it becomes positive. When you do a negative to an odd power, it will be negative. So this is a negative to an odd power. That means our result will be negative x to the 5th. This one here is a negative to an even. So the negative x is just going to become x to the 4th, but we still have the negative 3 out front. So the negative 3 comes down, but this part, the negative x to the 4th, becomes a positive x to the 4th. In the next one, we have got a negative raised to the 3rd. So that's going to become a negative times x cubed. Put that negative out in front of the 4, negative x cubed. When we go to the next one, what we're going to see is a negative raised to a 2nd. That's going to become positive. So we're going to have a positive 10x squared. And the next one, what we see is we see a negative 3 and a negative x to the 1st. That's going to be a positive 3x. And then last but not least, we've got a plus 5. So we are looking for the number of sign changes. So from here to here, actually, let me just kind of really emphasize it. Negative on the first one, negative on the second one. On the third one, we're negative. Positive on the 4th, positive on the 5th, positive on the 6th. We are looking for the number of sign changes. There are 0 sign changes here. 0 here. There we've got 1. Now 0, now 0. What this tells us is the number of negative zeros in this case will be 1. We know there will be 1. We can't reduce that any, so we have 1 negative 0. Okay? So there is how Descartes' rule of sign works. We're going to look at one more example, and we're going to let you practice some for homework this evening. For this one, we are written in descending order again. It's always going down each time. So we're looking for the signs. We've got a positive followed by a negative, then a positive, then a negative, then a negative. So if we're looking for sign changes, we got 1 there. We have 1 there. There's another one, not there. So we've got 3 sign changes, which means we will have either 3 or 1 positive zeros. Okay, it's either the number of sign changes or the number decreased by an even integer. Now we're going to come down here, we're going to substitute in negative x. We're looking for the number of negative zeros that are possible with this problem. Again, this is negative x to the 6th. That's going to just be x to the 6th when we do that out, so I'll carry that down. In this case, we got negative x raised to the 4th. That will be just x to the 4th, but it's times a negative 2 out in front, so negative 2x to the 4th. In this case, we've got a negative x squared. That's going to end up being just positive x squared because all of these have even powers, so we're going to have plus x squared. In this last one, it's really negative x times negative 7. So that's going to end up being a positive 7x. And we've got the minus 5 at the end. So here are our signs. Positive, negative, positive, positive, negative. One sign change, another sign change, no sign change there, one sign change there. So we are going to have either 3 or 1 negative zeros. So here's the deal again, Descartes' rule of signs. It won't tell you the zeros, but it will tell us how many to predict. So when we're doing future problems, we can take a look at it. We can say, hey, we know there's going to be no more than whatever, 3 in this one. There's going to be 3 or 1. And we'll know when we're looking for them how many to expect. Hope that makes sense. Again, just one short section here on Descartes' rule of signs. Good luck with your homework on this, and I'll see you guys next time.